Let's do an example. An ice cube floats at the surface of a glass of water. The density of water is 1,000 kilograms per meter cubed, and the density of ice is 917 kilograms per meter cubed. The ice cube measures 2 centimeters on its side. Find the mass of the ice cube. I'm going to start by finding the volume of the ice cube by using the fact that for a cube, the side cubed equals a volume. I'll take 2 centimeters and convert it to 0.02 meters and cube that, which will give me a volume of 8 times 10 to the negative 6th cubic meters. Now I'll use the density of ice to solve for the mass. The mass will equal density times volume, which is equal to 917 kilograms per meter cubed times 8 times 10 to the negative 6th meters cubed, which gives me a mass of 7.336 times 10 to the negative 3rd kilograms. B, find the weight of the ice cube. Well, we know that weight is equal to mass times the acceleration of gravity. So I'll take my mass from part A, 7.336 times 10 to the negative 3rd kilograms, times 9.81 meters per second squared, and that gives me approximately 7.2 times 10 to the negative 2nd newtons. I'll be coming back to these numbers later. Find the weight of the water displaced by the ice cube. Well, this is what Archimedes' principle gives us. Archimedes' principle says that the answers to B and C must be the same. So if I have an ice cube, sketch one here, and I place it in the water, it says that whatever water is displaced is equal to that buoyant force. To remind myself, I'll draw a quick sketch again. There's my buoyant force, and this buoyant force must equal the weight of the water displaced. That's the water pushed out of the way by the portion of the ice cube that's underwater. D, find the volume of the water displaced by the ice cube. Well, we just figured out the weight of the water displaced by the ice cube. The weight of the water was approximately 7.2 times 10 to the negative 2nd newtons. And I know from a previous calculation that that corresponds to a mass of 7.336 times 10 to the negative 3rd kilograms. And now what I'd like to do is I'd like to find the volume, and I would do that by using my density. And there's the density of water. It's 1,000. So doing a quick calculation, I would get that the volume is equal to 7.336 times 10 to the negative 6th cubic meters. E, what volume of the ice cube will stick out of the water? Well, we figured out that the total volume of the ice cube was 8.0 times 10 to the negative 6th cubic meters. That was from part A. And we just figured out that 7.336 times 10 to the negative 6th meters, cubic meters, is under the water. So the difference between those is 6.64 times 10 to the negative 7th cubic meters. F, how high will the ice cube stick out of the water? A sketch might be useful again. I'll do a quick sketch of a cube. I know that the volume that sticks out of the water is equal to 6.64 times 10 to the negative 7th cubic meters. And I know that the cross-sectional area of the cube is equal to an area of a square that is 2 centimeters on a side. Oops, I think I got one too many zeros there. So the unknown is this height. If I take the cross-sectional area and multiply by the height, it will give me the volume from part E. So 0.02 squared times that unknown height equals 6.64 times 10 to the negative 7th cubic meters. When I solve that, I get 0.00166 meters, which is equal to 1.6 millimeters.